Hey everybody, and welcome back to Kerbal Space Program, Taki Space Program. So last time we completed our first contract and got a rocket up to 50 kilometers. So let's see what Mission Control has for us next. Ooh, lots and lots of contracts. So we have a V2 rocket, which means... So, I've been talking a lot about contracts, and let's show you how they work. So you click a contract over here and it pulls it up. A lot of this is just fluff text. It's extra stuff that you really don't need to worry about. What we are worried about is the expires, and this is how long we have to complete this contract, and the objectives. So this rocket needs to escape the atmosphere and reach space. So it needs to be unmanned, it needs to reach space, and it has to fly above 70,000 meters. We can do this. We have a rocket that'll do it. It's just a matter of getting that rocket to work. So I'm going to go ahead and accept that one. And this one, all we have to do is test a TR2V stack decoupler at the launch site. That's actually pretty easy to do. I'm going to go ahead and accept that one. So let's build our rocket. Now this rocket, all it has to do is reach space. It doesn't have to go into orbit. It doesn't really have to do a whole lot else. So this I should be able to just modify the last rocket I used for this mission. Just a little bit. So I'm going to go ahead and load it up. I'm going to swap out the decoupler down here because one of my contracts is let's move that over there. Oops. Is to test the TR2V stack decoupler. So I need to find that. There you go, TR2V stack decoupler. There it is. Go ahead and close that, move that back over here. I'm going to make it 1.25 meters just so I have something I can put on. So, pro tip. To select your entire rocket from anywhere on the rocket, you hold down the shift button and click, and that will select your entire rocket, and you can move it around, put it wherever you need to, instead of having to scroll up here and then grab the root part and hoping you get the right part. And it just saves you some time. It's a little bit easier. You don't have to worry about it as much. I have one part left, so I'm actually going to change this a little bit. See if I have. Do I have the required fuel tank? I do not. That is unfortunate. So, I can't actually use that engine yet. So what I need to do is put that back. Oops, there we go. Put that back on there. I need to figure out how to make this rocket stable. I only have one part to do it. You know what? This is going to take some fancy flying. I'll worry about it in a minute. So, let's... Ooh, that actually gives me an idea. Nope, that's too tiny. So I've added this piece on the bottom here, and hopefully that will keep my rocket a little more stable, but just in case, I'm going to change my staging down here so that it will fire my engine at the same time I decouple. And I need to fix this staging here. Oops. There we go. Now, I like having my decouplers and my engines in different stages, at least for the early tech. You can have them in the same stage, and that way your engine will ignite at the same time as your decoupler fires. It'll give you a nice boost, but it's not required. So, I'm going to go ahead and recondition the launch pad, and you have to recondition the launch pad after every launch. What this does is it clears off any debris, gets rid of trash, and basically gets your launch pad ready for the next launch. Now we're going to complete our rocket. Oh, I'm researching things. Okay. So we're going to research some stuff. I forgot about that. Yeah, we got stuff that needs researched. So on our next mission, we'll have a whole bunch of new parts we can use. Yeah, this looks like it's going to be maybe well, it looks like a midday, maybe an early afternoon launch. Beautiful weather down in Florida right now. Take us a little less than an hour. So, let's go ahead and launch our rocket, shall we? So here we are on the pad, ready to launch. Oh good, my wider base worked out perfectly. So by having this wider base on here, my rocket is now standing tall, and it's not going to tip over very easily. So we're going to turn those on, and now watch. See, we're on Earth, we're at the launch site, and this note here says to activate the part through the staging sequence. So there it is in the staging sequence, and launching in 3, 2, 1, liftoff. And there we go, we've completed that contract. So already our mission is at least a success in that regard. So we're going to go straight up for a little bit, and like I said, we're going to perform a gravity turn no faster than 100 meters a second and no higher than 1 kilometer. So here we go, 80... I like starting mine about 95 meters per second. And it's just a nice number. It gives me a little bit of a cushion. So we're going to go. And as we perform our gravity turn, notice my inclination down here. Now, the Earth is tilted by about 23.5 degrees on its axis. Now, this is basically what gives us our seasons. Well, it plays into our seasons, not the whole thing. But Florida is close to the equator, but it's not quite on it. Which is where this inclination is coming from. That's the lowest I can go while still maintaining or while still launching east. So here we go. I have a little bit of a plan to stop the spinning or the flipping. So my apoapsis is about 58 kilometers, which is good. So I'm just going to coast for a little bit. And the reason I'm coasting, and if you notice my rocket is staying much more stable, is because this upper stage engine here doesn't have a gimbal. So it's not going to move and adjust my rocket for me. So by having this weight here, it's keeping my rocket stable for me until I get to a point where I don't have to worry about my rocket flipping anymore. And I'm actually right about there now. So I'm going to go ahead and ditch the first stage, cut my engine. There goes the first stage, and there goes my rocket. See it already starting to flip. That's okay. We're just going to come around. Now, we're going to go full throttle, and to do that, I'm going to hit the Z key. And here we go. And again, because this rocket is not very aerodynamic at this point, the center of mass is probably somewhere in the payload, and that's just not... It doesn't work very well when trying to fly. Okay, here we go. We're starting to regain control. Nope, what are you doing? Oh dear. So this rocket does not want to play well with others right now. It's kind of annoying because here I am trying to complete this contract with a rocket that doesn't want to work. So I'm fighting it. Alright, this'll work. Now it may look like I'm burning all over the place, but what I'm really doing is I'm burning up. And as you can see, that's increasing my apoapsis. I'm now actually starting to go up. Cut my engine, come back around. Like I said, my ultimate goal is to get to an apoapsis of greater than 70 kilometers. I don't have to get to orbit. I don't have to worry about any of that. And there we go. We have an apoapsis of greater than 70 kilometers. Now I'm going to get a little higher than that, just in case. And there we go. We're above 70 kilometers, and we have completed that contract. But now that we're up here, I'm going to see if I can put this rocket into an orbit. And I think the reason that, yep, it's a lot more stable now. Nope. So, the reason my rocket keeps spinning out of control is because the payload is unbalanced. There's more weight on one side than the other. So I'm just going to go ahead and ditch that stage because there's no reason to have it anymore. I'm going to fire this engine that does have a gimbal and is capable of compensating for that unbalanced payload. You can see the engine moving around there as it makes corrections. Now, of course, this rocket's not going to make orbit anymore. And while we're in space, I'm going to go ahead and run all my experiments. Oh wow, it almost made orbit. Almost. So this rocket's going to re-enter, and again I'm going to adjust and arm my parachute just in case. I'm going to point retrograde. That's what this little symbol means down here. This means retrograde, which is against the direction of motion. So as you're watching, I'm moving from left to right, but my rocket is pointed from right to left. So if I would fire my engine right now, it would actually slow me down just a little bit. And in fact, that's what's going to happen when I fire this decoupler here. Yeah, slow down just a little bit. And hopefully that's enough to bring me down safely. I say safely. This is Kerbal Space Program. Anything could happen. I would like to recover this rocket because that would give me quite a bit of science. But it is not necessary at all. So if you notice, I'm checking my electric charge and my ablative shielding. This is my resource panel. This tells me every resource I have on my vessel. And right now, my big concern is electric charge. Because if that runs out, I will no longer have control of my rocket, and it could explode during re-entry. So, I've entered the atmosphere, and my periapsis is dropping because the atmosphere is slowing me down. Now, you're probably thinking, if the atmosphere is slowing you down, why is your speed increasing? And that's because I'm getting closer to periapsis. So the increase in speed is overcoming the atmospheric drag. Here we go, coming down, maybe. And we're approaching periapsis. Now, when you re-enter, especially for manned missions, and now atmospheric drag is starting to take over, and it is actually starting to slow me down. But especially for manned missions, you don't want to re-enter too steep, because at that point, your re-entry heating is going to happen faster than your heat shield can dissipate it. So you want to pick a nice angle. Generally about 35 to 45 degrees is fine. You can put your what I like to do is put my periapsis at about 30 kilometers above the surface, and that just allows me to sit back, relax, and know that my capsule is going to come down in one orbit. This actually looks like it is going to come down in one orbit, just based on how much my periapsis is dropping. It's going to take me a while to get there, but these things happen. So now we wait, and we wait, and we wait some more. So there is the camera switch. We're now officially coming out of orbit, and we are going to return to the surface. And we can see our periapsis here dropping. I'm actually coming up on my launch site, which is the downrange distance. I'm moving at a little less than Mach 7. So that's roughly 7 times the speed of sound. And of course that's going down because I am returning to the surface. Now my periapsis has gone negative here, and what that means is that it is intersecting the surface, and I am definitely going to come down somewhere. I just don't know where. Judging from this, looks like it's going to be in the middle of the Atlantic, maybe off the coast of South America there. Looks like off the north coast of South America, which is fine. Passing over Cuba and the Bahamas. There's Florida to the north there. Beautiful work by several different mod authors. The mod I'm using for Earth and the Moon and the solar system in general, yeah, there's the whole solar system, is called stock size real solar system. And what it does is it takes the solar system and makes it stock sized. So we've passed through the thick atmosphere, or the thinner upper atmosphere, and now we're into the thicker atmosphere. I've lost my connection. There goes the chute in semi-deployed state. And that's why I armed my chute early, so once it reached the appropriate altitude, it would deploy automatically. I didn't have to worry about it. So we're falling into the ocean. Just off of, I'm not entirely sure where we are in the world, actually. So yeah, we're just north of South America there. The chute goes fully deployed. That is a beautiful sunset provided by the Scatterer mod with, I believe I have the stock visual enhancements installed as well. But that's what gives me the awesome water, the clouds, the beautiful sunset. I mean, just look at that. And now we're going to sink. So, what I did there was I toggled my UI, or my user interface, and to do that you hit F2. F2 hides the user interface so you can get beautiful shots just like this. And if I wanted to take a screenshot, I'd press F1. And I would take a screenshot and it would save it in the KSP directory in the screenshots folder so that you could put it up on Facebook, set it as your background, what have you. So now that we're back on the surface, I'm going to go ahead and recover this vessel and just see how much science we got. Oh wow, we got 40 science that mission for a grand total of 55 science overall. And we have 274,000 funds to spend. Looks like some of our debris survived, so we're going to go ahead and recover that and get some funds back. And that's it for this episode. Next time we're going to spend our science, we're going to see what other contracts we have, and we're going to keep reaching for the stars. Until next time, I'm Taki117, and remember, it's just rocket science.